Hello friends, welcome to the channel of Digital to Real. Today I am going to talk about Verilog scheduling semantics. It is a very important topic of Verilog. Now the RTL design and the test bench design has many always or initial blocks. They have many continuous assignments also, that is the assign statements. So we write the RTL code, we write the test bench code in Verilog, module end module, module TB end module. We introduce the always block there, we introduce the initial blocks there, we introduce the continuous assignment statement there. So there are many of them. Now scheduling semantic means what? That means what is the order of execution of the always blocks, that is the multiple always block, multiple initial blocks, multiple continuous assignments in the same module and module. Because they are all procedural blocks which get executed concurrently. So which always block is executed first, which second, this all things is determined by the scheduling semantics. They are active at different point of time in the simulation cycle. That is what means some always block are being triggered at first and then the continuous assignment statement is triggered. In some cases, the assign statement is triggered first and then the always block is triggered. So, they are all active. These all statements are active during the simulation cycle at different point of time. Whenever there is any change in the value of the signal in the Verilog model, it is called update event. So, for always block, we provide the sensitivity list. Even for the assign statement, the left hand side is assigned the right hand side value. Whenever there is a change in the sensitivity of the always block, we go inside the beginning statement of the always block is triggered. Similarly, whenever there is a change on the right hand side of the assign statement, the assign statement itself get triggered. So, these are called update event. Mean any variable is going to change. Any variable is changing. That means any event is updating. Assign statements and always block in the RTL model are sensitive to update event. Update means any change in the values of the variables and are evaluated in an arbitrary order called an evaluation event. That is what I said. They are all concurrently executed, but they are being picked up by the simulator at arbitrary order. And that is called the evaluation event. So inside the module end module, there are many statements. Procedural, continuous, delay elements, non-blocking assignments. So many statements are there. So which statement will be executed at what time? So that depends upon the scheduling mechanism. And these are all events. They are called events. The statements are called events. They can happen at different time. And event queues are used to manage and ensure the order of executions. So all these instructions are put into certain queues. Some goes into active queue, some goes into the non-blocking queue, some goes into inactive queue, some goes into the monitor queue. So these queues are used to manage and ensure the correct order of execution. The standard Verilog documentation, the scheduling mechanism has already been mentioned. So we have to code the Verilog code as per them. So module TB reg A, B, C semicolon A, B, C are 3 register and D is of wired type. Wired D semicolon. We are writing a test bench module. So inside the comments I have put, always is a process that gets evaluated when either A or B is updated. So here is the always block for the code. Always at the rate of A or B begin in end, and inside that C is equal to A and B. So whenever A changes or B changes, C is equal to A and B is triggered. So always is a process that get evaluated when A or B is updated. Change of the value of A or B is called the update event. When always block is triggered because of a change in A or B, it is called the evaluation event. Now in the code, I have an assign statement also. Assign D is equal to A or B XOR C semicolon. So now assign is a process which get evaluated when either A or B changes value. Here also, whenever A and B changes value, this statement is get triggered. Please note here D has a dependency on C. And here in this always block, C is the output is equal to A and B. So if both are triggered at same point of time, some confusion can happen. What value of C would be put here? Let's see how the scheduling mechanism helps in that. Verilog event scheduling queues look like this. First type of event is the active region. And this is the active queue. Okay, what type of statement comes under active queue? Blocking assignment, right hand side of non-blocking assignment, continuous assignment, $display command, UDP, that is user defined primitives. They come under this active region of the queue. Then is the inactive region, that is has 0 blocking assignment, has 0 delay. 0 delays come under the inactive region. So the order of execution is in this way only. First active region, then inactive region, then comes the non-blocking region. So updation of the left hand side of the non-blocking assignment. Whatever the right hand side values have been evaluated, that would be assigned to the left hand side in the next clock pulse. So that is comes under non-blocking region. And after non-blocking region, at last comes the $monitor and $displays. So they comes under the monitor region. So the monitor queue forms here. Now we will look into the non-deterministic simulation. During the simulation, there can be race condition that end up giving different outputs for same design and test bench. Okay, so the race condition can come up when 2 or more multiple processes are triggered simultaneously. The order in which processes are executed is not specified in IEEE standards, which I told is that in active event certain type of instructions are there. They are being picked up during the simulation and they are executed. If they are initial begin end, inside the initial begin end, sequentially they will execute it. If the always and assigned statement are there, then both will be triggered at same point of time. And irrespective of the order, they will be executed. But if there is some dependency, this order matters, as the order of execution is not mentioned in the IEEE standard. Case 1. Always at the rate of D, Q is equal to D semicolon. This is the first statement. Means whenever the D changes, Q is updated to the value of D. This is first. Second is that whenever the D changes, not of D is assigned to Q. Both will be triggered at the same point of time. Do you realize that? Okay. So whether the Q will get the D or not of D value, that is a confusion. That is actually the race around condition or the non-deterministic simulation. Now here is the case 2. Here is another set of event which is non-deterministic. Always at the rate of passage of the clock, begin x is equal to 1 tick b0 semicolon, y is equal to x semicolon end. This is one always block. There is another always block. Always at the rate of passage of the clock, inside begin and x is equal to 1 tick b1. You see, x is equal to 1 tick b0. So this one and this one, x is equal to 1 tick b1, they will be triggered, both the always block will be triggered at the passage of the clock. So both this statement, both this x and this x will be executed at the same point of time. So what value of y would come, that is non-deterministic, whether y is equal to 0 or y equal to 1. So the both always block are triggered when a passage of clock arrives. One order is x is equal to 1 tick b0 semicolon, y is equal to x semicolon, x is equal to 1 tick b1 semicolon. In this case, y gets the what value? 0 value. Another order is x is equal to 1 tick b0, x is equal to 1 tick b1 semicolon, y is equal to x. Here the y gets 1 value. So what value the y will get? That is non-deterministic. So this is the Verilog scheduling semantics. If you like the video, share with your friends. Please subscribe the channel and have a very nice day. Bye-bye.